welcome you all to this lecture. Here, this is the continuation of our previous one where we have started the differential equation. Now, we will be continuing with the same thing, and here the first term, it is homogeneous differential equation. Homogeneous differential equation. So what is homogeneous differential equation? Say an equation of the form dy dx is equals to fxy by phi xy. It is said to be homogeneous, where f and phi, these are homogeneous function of same degree. So what is the meaning of homogeneous function? So for that, we'll take help of one example and we'll try to understand. Okay, so prior to that, let me introduce one definition to you. See here, this term, a function f is said to be homogeneous if what you have, f of tx comma ty is equals to t power n f of xy, that is homogeneous function of degree n. Okay, where t is independent of x and y, basically it is a parameter. Okay, so this is the definition for homogeneous function. Now how it works, we'll see through example. Okay, so homogeneous differential equation, already we stated the definition. Now when we have homogeneous differential equation, then the method of solution, it is given by, you substitute y is equals to vx, and then separable variable method will be there immediately. Okay, so for example, we can take this question. Suppose this question, okay, I'm considering this question. Solve x square y dx minus x cube plus y cube dy. So this setup, immediately you can consider like this: m dx plus n dy form is equals to 0. Okay, immediately you can consider like this, and you can check whether it is exact differential equation or not by checking del m del y is equals to del n del x or not. You can check this one. If it is exact, then immediately you can apply that previous formula. For that, you can refer our last lecture. So this thing you can check first, because in the exam, suppose one differential equation will be given to you, but which method you need to apply, that you need to decide by yourself. Okay, so that's why first thing is check whether it is exact or not. If exact, then just simply apply that previous formula. Otherwise, next you check whether it is homogeneous or not. Okay, so for that, see, this equation can be written as, I'm just giving you the idea for solution. So solution for this question, so this equation can be immediately written as, see, dy dx is equals to x square y by x cube plus y cube. Now see, this numerator and denominator, both are polynomial functions and they are having degree 3. Okay, numerator and denominator, they are having the same degree. So that's what here it is written. See, f and phi are homogeneous function of same degree. Okay, same degree. Then you can apply this method. Okay, this method. Now see, what you need to substitute, you need to substitute y is equals to vx. This thing you need to substitute y is equals to vx. So from here, dy dx, what will be dy dx? You apply that product rule, so you'll be having x dv dx plus v. Apply the product rule and now substitute here. So what you have, x dv dx plus v, and here what you have, x square y means vx, you can put here, x cube vx whole cube you can put here. Okay, so in the next step, what you have, vx cube, and here you can take x cube common, and here you'll have this one. Okay, so from here, if you calculate x dv dx plus v, that is equal with v by 1 plus v cube. All right, so in the next step what you have, x dv dx, here v by 1 plus v cube minus v. Okay, so if you do this, and you'll have v minus v power 4 by 1 plus v cube. All right, so if you further do the calculation, dv dx, that is equal with minus v power 4 by 1 plus v cube. All right, so in the next step, just follow this one. Next step, see here, I'm continuing this side. So immediately what you will have, see, one plus v cube by v power 4 dv is equals to minus dx by x, So here this separable variable method you are applying now. Okay, so here what you have, 1 by v power 4 plus 1 by v dv is equals to minus dx by x. Take the integration now. Okay, so what you have, see here, integral v power minus 4 dv plus integral dv by v. Here you have minus integral dx by x. So here v power minus 3 by minus 3 plus log v is equals to minus log x, plus you can simply introduce c. So here what will be in the next step, minus 1 by 3 v cube plus log v means y by x is equals to minus log x plus c. So v means what, y by x, so immediately minus x cube 3y cube plus here what you have, log y, next minus log x is equals to minus log x plus c. So this minus log x cancels, so immediately what you will have, minus x cube minus x cube by 3y cube minus x cube by 3y cube plus log y is equals to c. This will be the final solution. Okay, so try to do the solution by yourself, and if you stuck at any point you can refer to this calculation. Further you can simplify this form as well, but up to that, that is okay, you can keep up to this, no problem. Now this first question, it is immediate question, and already in the class we have solved this one. So basic form is this one, what, dy dx, you can write this dy dx as x square minus y square by xy. So in the class already I stated that you have you can divide both side, numerator and denominator, by x square, so that you get y by x form and substitute y by x equals to v. That is one way, or you can simply substitute y is equals to vx. Actually it is same. Okay, so you can do the solution as well. Okay, so try to solve this question, and if you find any difficulty, let me know in the comment section as well. Now see, we are moving to the application related question. See this question, where homogeneous differential equation is there, and basically we are having one application. See, suppose that the rate of increase in cost of ordering and holding y as the size of order s increases is equal to the ratio of the sum of the square of cost and the size divided by twice the product of cost and size. Find the relationship between cost of ordering and holding, and size of the order. Okay, so basically cost of ordering and holding, that is y, and size of the order, that is s. Okay, so basically y, it is function of s. Okay, so basically y, it is function of s. Okay, so basically y, it is function of s. Okay, so basically y, it is function of s. Okay, so basically y, it is function of s. Okay, so basically y, it is function of s. Okay, so basically y, it is function of s. Okay, so basically y, it is function of s. Okay, so basically y, it is function of s. Okay, so basically y, it is function of s. Okay, so basically y, it is function of s. Okay, so basically y, it is function of s. Okay, so basically y, it is function of s. Okay, so basically y, it is function of s. Okay, so basically y, it is function of s. Okay, so basically y, it is function of s. Okay, so basically y, it is function of s. Okay, so basically y, it is function of s. Okay, so basically y, it is function of s. Okay, so basically y, it is function of s. Okay, so basically y, it is function of s. Okay, so basically y, it is function of s. Okay, so basically y, it is function of s. Okay, so basically y, it is function of s. Okay, so basically y, it is function of s. Okay, y is dependent variable, s is the independent variable here. Okay, so rate of increase means dy ds, that is equal with the ratio sum of square of the cost size and sum of the cost and the size. Okay, so that is sum of the cost, that is y square plus s square divided by twice the product of cost and size, so 2y into s. So this is the governing equation we are having. Okay, this is the governing equation for this question. Okay, now we have to solve this question and find the relationship between y and s. This is the question. Okay, and ultimately at the end we need to find size of order. If y is equals to, see, that relationship we need to find, and we need to take help of this condition, that is y is equals to 3, that is y is equals to 3 when s is equals to 1. This condition we need to take so that the arbitrary constants value we can find. So basically particular solution we are trying to investigate. This is the question. So now see, numerator and denominator, they are nothing but polynomial function of same degree, 2 degree. Now what you can do, y is equals to vs, this thing you can substitute, so that here dy ds, it will be, why you are finding dy ds, because dy ds it is required here. Okay, that's why. So v plus s dv ds. So if you apply this one here in this equation, so I'm writing here, so it will take the form v plus s dv ds is equals to, y is equals to vs, so vs square plus s square by 2 vs into s. Okay, so if you further do the simplification, so v square plus 1 into s square 2v s square. So if you do this one, v square plus 1 by 2v, that is equal with v plus s dv ds. Now in the next step, s dv ds, that will be equal with v square plus 1 by 2v minus v. So from here 1 minus, do this calculation, 1 minus v square by 2v, that you will be getting. Okay, so immediately in the next step, follow here. In the next step, what you will get, 2v by 1 minus v square dv, here you have ds by s. So now you can do the integration both side. So integration here I can do integration here, plus you can introduce log c. Why? Just for the sake of calculation simplicity, nothing else. Okay, you can simply take c as well, no problem. Now see here, what you have, 2v, the derivative of this term is minus 2v, so you can adjust this one, that minus here minus 2v, 1 minus v square dv. While doing this type of calculation, make sure you know all the formulas of integration from 12th standard or 11th standard, whatever you have, those formula you should revise. Log 1 minus v square, here what you have, log s, here log c. So 1 minus log v means, what you have, v means, v is what, v is y by s, so 1 minus y square by s square log s plus log c. Now here minus log s square minus y square, here minus plus log s square, square here by the rule of logarithm, So log s present here plus log c. Now in the next step, minus log s square minus y square, that is equal with log s, here log c. So in the next step, what you will have, log s by s square minus y square, that is log c, and s by s square minus y square, that is c. So now you can apply those values here. So s is equals to 1 and y is equals to 3. So 1 by 1 minus 9, that is c. So c value you will be getting minus 1 by 8. So if you back substitute c value here, so basically you are going to get s by s square minus y square minus 1 by 8. So y square minus s square is equals to 8s. This thing you must get. Okay. So yes, exactly this one. So the simplified form you can write. So here y square you can write 8s plus s square, and if you just omit this square, so here you have half. All right, so 8s plus s square power half. So this thing you are going to get. Okay, so this is the entire solution you have. Okay, all right, so this is homogeneous differential equation and its application. So this type of question you should practice. Okay, now next what we have, it is linear differential equation, homogeneous and second order. Okay, so here you can observe the general solution of homogeneous equation with constant coefficient. So far whatever the application or whatever theory we discussed, those are related to first order only. Okay, now this is the first time we are introducing second order linear differential equation. This side 0 means it is homogeneous. Here p and q, these are constant terms. To be very specific, for this module, p and q are constant term. Okay, so our target is to investigate solution of this type of equation. Okay, now first we'll consider one motivation, what will be the approach, and gradually we'll have different methods. For example, variation parameter method of undetermined coefficient. But before that, one method, it is known as by applying a trial solution. Okay, trial solution. So what is the motivation behind this trial solution, we'll see. Okay, so just take this equation and for few moment you just consider one standard equation, that is y dash minus y is equals to 0. Okay, at the very early days, when the methods were not so much developed, softwares were not available, that time the initial step was to have some trial solution. Okay, whether those solutions hit or not. Okay, a hit and trial basically. So for that, if you consider this equation and if you consider y is equals to e power x, see y dash is equals to e power x as well. So this y is equals to e power x, it satisfies this equation. So basically this is one solution. Not only this, y is equals to, if I write 2 e power x, this is also a solution. Y is equals to 3 e power x, this is also another solution. Likewise, you can consider y is equals to c e power x, where c is any value, any arbitrary value. Okay, so this is also a solution. So in that case, what you have, so for this type of equation, immediately one can get y is equals to c e power x as the general solution. Okay, so somehow you can get the idea that for this type of differential equation where constant coefficient it is involved, c into e power x, that is basically the exponential part, that is e power x, somehow it will work like a trial solution. So for more generalized version, one can easily take y is equals to e power mx to be a trial solution. Y is equals to e power mx to be a trial solution. So if you just consider this one, then immediately see y dash, you can get y dash, y dash is equals to m e power mx, y double dash you can get m square e power mx. So if you just plug all these things here in this equation number 3, immediately this form you are going to get, okay, immediately. And you can take e power mx common, and ultimately you have this equation. E power mx, this exponential part cannot be equal with 0, so what you have, this part, it is 0, which is nothing but quadratic equation in m, quadratic equation in m. So two values of m you are going to get from this equation. So based on the values of m, you have total two cases, okay, when m real and when m imaginary. Okay, if real, then you have two cases, real and distinct, whether m values, suppose m1 and m2 you are going to get, they are real or distinct, and real and identical. Okay, so based on these, basically real distinct, real identical, and imaginary, you have total three different cases. Okay, so based on the values of m, we'll have those situation one by one. Okay, so today we are stopping up to this. Okay, in next class we'll see how we can formulate those solutions, or the form of the solutions, how we can generate. Along with that, we'll see independent solution, linearly independent solution, criteria for that. Okay, so thank you, we'll meet in our